Started. Hello, everyone. Good morning and good evening. Good morning to our audience in Taiwan, and good evening, audience in the other half of the world. And it's a great opportunity that we meet together here today. Let me just shortly introduce what this colloquium is about. Actually, this is Carl and I. We made this project, and then we try to pull those top-notch scholars together, and then try to share the data analytic, especially in the area of public policy and science. So this is a great honor today that we have Dr. Whitten here. And just let me tell you that this is sponsored by the university, the Chongqing University, National Chongqing University in Taiwan, and then, of course, UTD. And then I think that we're off to a great start, especially that we had Dr. Harold Clark today here, and he's our inaugural speaker for this series. And we're looking forward to more top-notch scholars such as Dr. Clark and Dr. Whitten. Actually, we're expecting to, Jeff Gill, Dr. Jeff Gill for next Friday. So actually, this is a very strong cast for this colloquium. Looking forward to even more develop to a bigger community, and so everybody can share the knowledge, and there's a good platform for each other to exchange. So this is why we initiate this one. But there's still a lot of things that we need to improve. But I just want to say thank you for all the audience to join us, and thank you for all the speakers here. Carl.
Hello, hi, thank you, Peter. Thank you for giving a great introduction. Allow me to quickly talk about our speaker, honorable speaker tonight. Professor Guy D. Whitten is a professor at Texas A&M University, and he's also the director of the European Union Center at the university. And recently, he has been busy with conferences and talks about the developments in EU and also COVID in Europe. And Dr. Whitten's primary research is on political economy, political methodology, comparative politics, and public policy. And he has been famous for his textbook. The title of the textbook is Fundamentals of Political Science Research. Now, this book has been translated into other languages already. And now it has come to the third edition. Is it third edition or fourth?
It's third.
Professor, third, okay. Now, he's also editor of the Cambridge University Press book series, Methodological Tools in the Social Sciences. And now he's currently sitting at on the editorial board of Political Analysis and Political Science and Research Methods journals. These are the most well-known journals in political methodology. Without further ado, allow me to introduce Professor Guy Whitten.
Thank you very much. It's an honor to be here. I really want to thank Peter and Carl for inviting me to be a part of this series. I was looking over the website earlier, and a lot of really great people to be in the company of. Certainly Harold Clark, my old friend, and we've co-taught all over the world together. And so it's always a pleasure to be there. I'm very honored that he's here too. Yeah, I'm going to be talking tonight about a project that's it just keeps growing. It's been a really fun project, and it's what I'm going to do is kind of give you guys an overview of this project. And in the project, what we're doing is we're looking at the dynamics of trade-off relationships. And I find that once you start looking at the world this way, you see these kind of trade-off relationships all over the phenomena that we study. And this is a place where the relationships between theories that we develop have been driven by, and we would argue, a fair bit limited by the types of statistical models that we estimate. And we argue that until recently, we've done a pretty poor job of statistically modeling trade-off relationships, particularly as they evolve over time. And what we're trying to do with this project is to bring our theory building and our empirical models closer to reality. And in our initial work along these lines, we introduced our approach to modeling time series for a compositional dependent variable with a single time series over time. We've now expanded the scope in several different directions. I think we have 6 papers published in the project, and about 10 that we're working on, and a bunch of different pieces of software that we've made available. And so you know, a lot of this work, as you'll see tonight, is very much in progress, and I'm looking forward to getting your reactions to it. I should say, I mean, I'm happy to be interrupted if people have clarifying questions. I know, you know, in the Zoom or the Teams environment that you know, just having one person drone on and on can be a bit monotonous, and I definitely would be happy to engage with people at any point if you have questions. And Carl, I don't know if I don't know that I'll see if people have questions, so you can interrupt me if you see people.
Sure. And
please
yeah,
do.
I'm monitoring the conversation box, and anyone who would like to ask a question, you can type in the conversation box, then I can relay it to Dr. Whitten. Yeah.
Great. And so, you know, tonight I'm going to give you an overview of the project with an emphasis on some of our current work on political budgeting and income inequality. And so, you know, as an outline, I'm going to talk through some of the initial ideas and where they came from, where the project came from, talk about some of the initial papers and the first piece of software, and then talk about the methodological and substantive extensions and some of the future directions and things that we're thinking of working on or just beginning to work on. So I guess when I think about the origins of this, it kind of started to form in my head and stayed there for a long time. But I'd say around about 2011, when I was getting ready to do a conference on economic voting. We actually had 2, one at Texas A&M and one at Iowa, that was organized by Michael Lewis Beck, who is also part of the series. And
Yes.
Harold was at both of those conferences and was at the time the editor of Electoral Studies and published this wonderful collection of papers that came out of the 2 conferences. And so this is a figure from from my entry with Harvey Palmer in this. And what we're doing here is we're doing a very common style of paper. We got some excellent data that Harold had collected in the UK of monthly survey data, and we're modeling support for the party of the Prime Minister across this time, which of course in this era is the Labour Party. You know, this is a very common style of model. Lots of good papers have been done along the lines. And around the same time, I was starting to pay more attention to work on political budgeting and got really interested in that. This was a paper that I read and was really inspired by Christine Lipsmeyer, that was published in International Studies Quarterly, looking at how booms and busts affected spending of different governments of different ideological stripes. And so around that time, I did some of my own work on political budgeting, and this is work that I did with Larry Williams, and we were modeling spending as a percentage of GDP, spending on defense as a percentage of GDP, and you know, I started to see, even though these are, you know, these papers on support for the Prime Minister's party and spending on a particular budgetary category, even though they're very different substantive phenomena, I noticed that there was something that they really had in common, and that was that they were modeling one component of a dependent variable that's made up of more than 2 components, and they're modeling the evolution of that one component across time. And so I was kind of chewing on that, and it reminded me of some older work that I had done on individual level voting behavior. And so now we're going way, way back in time to 1996. Probably some of the folks in our audience weren't even born. But this was a time when people were just starting to use binomial logits and binomial probit models, and we were, as far as I know, we were the first people to publish an article in a political science journal using a multinomial logit, and that's kind of the point of this paper that Harvey and I wrote in the early 90s, that we were trying to convince people that they should use a multinomial logit. And so you can maybe already see where I'm going, but anyway, I'll just kind of talk about that project a little bit because it has this parallel, and this is around the time when I first started running into Harold at conferences and getting to know him, which was great. I think I gave a talk up at University of North Texas. I presented this paper up there. Anyway, this is a binomial logit model, which was typical of the way people were modeling individual level voting behavior all over the world. And we did the standard thing, which was to code the dependent variable is equal to 1 if the respondent said that they would vote for a party in the government, and 0 if they said they would vote for a party in the opposition. And then we said, well, by doing that, you're really pretty far away from reality and what we think about when we think about what's going on in the mind of the typical Dutch voter. And so we had a graph, and for back then that was actually pretty sophisticated looking graph by today's standards. It's certainly not. But we just take a hypothetical individual and hold them at the average for all of the other variables, and then vary their ideological placement from left to right, and we see how their predicted probability of voting for the government goes up. Okay, well, what we tried to make the point in this article was that you're really missing a lot of the reality of Dutch politics. And if you think about the governing parties that are lumped together in that one category, you've got the Christian Democrats and then the Dutch liberals, the VVD, and those are two really different parties in the one category. And then when you start looking at the 0 category of the opposition, you've got parties on the right, parties on the left, and so it's a really weird animal that you've created in order to model voting behavior. And what Harvey and I said was, you're really going to miss a lot of the action here, and it's also not reflective of what's going on in the mind of the Dutch voters. So we made a case for using the multinomial logit model. Here's a really awful table of coefficients, which was typical back then. And then we also made a graph, which this was really far out for back then. And what we're showing here is that by modeling 6 categories of the dependent variables, so the 6 major parties, and one of them is actually a party grouping over here, the Orthodox religious right, you're able to tell a much more nuanced story of Dutch politics, and one that frankly is very similar to what, if you went to the Netherlands back then and talked to experts about politics or reporters about politics, they would tell you, is going on the ground, that the voters have this very rich menu of parties to choose from. And then as we move them from left to right, this, again, hypothetical individual who's otherwise average on all their characteristics, we can see that their probability of voting for the left parties starts out big and then shrinks. Same thing here for Labor. But then the centrist D66, you can see it bulges in the middle and gets small. The Orthodox religious right, only a small sliver out on the far right. The VVD, the liberals, we can see, grows as we get further to the right. The Christian Democrats, who are center right party, bulge in the center right and then go down. So by making this move to a much more technically complicated model, especially for the 1990s, we're able to tell a story that just comports much more with reality. and in which we're able to test theories about what drives an individual, not just to make a decision to vote for the government or the opposition, but what drives their likelihood to vote for any one of these 6 major party groupings in the Netherlands. So flash forward back to, well, hold on. So here's the 2 graphs, right? And so what we were trying to do back in this paper in the early and mid 90s is to move people from modeling the world this way to modeling the way on the right. So now flashing back to our own work in modeling time series of party support and time series of single budgeting categories, it's the same basic issue where you're oversimplifying the dependent variable. There's nothing statistically wrong about doing it, and I want to emphasize that, but it's just a comparison that is a bit artificial and misses a lot of the substance and the nuances of politics. It also, misses out on the trade-off flavor, because in both cases, with political budgeting and with support for political parties, we're talking about a zero-sum game, where a gain by one party or one budgetary issue in terms of percentage of the budget must be offset by a loss by one or more of the other competing categories. And so that's why we call it the dynamic pie project. And basically what we're saying is that people who model support for the prime minister's party or spending on defense or welfare as a percentage of the budget or as a percentage of GDP are modeling just one slice of the pie. And they're implicitly lumping all this other stuff together. So when you model only spending on defense as a percentage of the budget, you're lumping spending on agriculture, spending on health, spending on housing all together. And those are really different animals. And when you lump, support for the Labour Party, the party of government in the UK, versus all the other parties, you're lumping the Liberal Democrats together with the Conservatives, and they're not the same thing. So that's where my thinking was at the start of this project. And just as an example of this, this is from the 2018 French presidential election, which in the run-up to the election, we had the Brexit vote, and suddenly there was a big surge in support for Marine Le Pen. And she's, of course, the candidate of the National Front. And, if you look at newspaper accounts of it, they were saying, oh, wow, Marine Le Pen has really become a contender. Her support has increased. And the big question was, where is she drawing her support from? Is she drawing it from the left, or is she drawing it from the right? And journalists and people who think about politics in France think naturally about this zero-sum trade-off relationship. When support for one party goes up, it has to come from somewhere, and it might come from several places, or it might come from mainly one. And so we wanted to move modeling from this scenario to something that looks more like this, where you're modeling, more of the slices of the pie. And so this is this kind of vague idea that I pitched to. I actually pitched it to some of my PhD students early on, and they said, no, I don't think that's going to be interesting. And so I put it away for a year or two, and then I pitched it to some others. I'll talk about them in just a second. Anyway, but one of the things about this project is, once you start thinking about the world this way, what you notice is that dynamically interesting compositional variables are everywhere in public policy and all throughout political science, and of course lots of other disciplines as well. And these are just a few of the subject areas that we've begun to model. and so that I'll be talking about. But there's lots more of them as well. And so this all gave rise to what we now call the Dynamic Pi project, and this is our website that we're just getting ready to launch. And you know, we have we're going to have a lot of different examples and programs that help people to use the software that they can check out when we finally launch this website. The first people that I pitched it to is one person will be quite familiar to you guys. I think he spoke a week ago here, Andrew Phillips, and another one was Amanda Rutherford. As you can see, they both got very good jobs. University of Colorado and Indiana University in Bloomington. Amanda actually got early tenure last year, so she's now an associate professor there. And they did the initial programming. They're the ones that when I pitched the idea to them, they took it and they ran with it. They really ripped into it. It was a pretty unformed idea that I'm like, it's kind of like a multinomial logit where you know the probabilities with some certainty. So, you know, but then you also have the complexity of time series. That's kind of the pitch that I gave them. And thank goodness they were young and had lots of energy and were extremely ambitious and capable. And then the two other folks here, Yu-Sun Chung, actually now has a postdoc at University of California, San Diego, and Flavio Souza is on the market this year, is still at Texas A&M. And they helped with the programming of the second piece of software, which I'll show you some results from later on. And then this is the group. It's actually gotten bigger. These were just the people that we listed in the initial making of the page. And we now have meetings by video conference every other week, attended by people from 4 different continents, which is a lot of fun. And we're you know, still having lots of fun. We have lots of different projects going on in that. And so here's another kind of figure thinking about what we're trying to get people to do, you know, in terms of, I've already talked about government budget, party vote. Income distribution is another example that I'll talk about later. Tax revenues, we've done some work on that, but it's just, it doesn't seem to fit quite as well with tax revenues. But basically, our idea is to improve on methods used by political scientists and other researchers to analyze compositional dependent variables by addressing 2 major limitations. First, although some researchers have considered compositional dependent variables, they've either done so in contexts that are not dynamic or in contexts that ignore the dynamic nature of their data. And then second, the current approaches that people have used to deal with compositional variables become really unwieldy when they have more than 3 categories. And I'll show you some examples of that. And so our strategy, and that, you know, I want to be clear, we haven't developed any new models. What we've done is we've kind of looked around and found models from lots of different disciplines and combined some tools that nobody has combined in the fashion that we've combined them to come up with a set of strategies for doing this modeling, and you know, showing the benefits that people can get from modeling phenomena this way, and providing a set of tools, mainly software tools, to allow people to understand and present their results from these types of models. So, you know, it's you know, got to put up some nerd slides with some equations on them, but I won't read through these. But it's basically the idea: what is a compositional variable and what is a compositional time series? The basic properties are that, you know, each component of the composition varies between 0 and 1. At any point in time, they sum up to 1. any changes have to be perfectly offset any changes to one category have to be perfectly offset by one or more other categories. And the basic bottom line point here is that you can't handle these types of dependent variables in a regression model, and that's something we've known for a long time. I think actually Pearson was one of the first people to realize that issue, and so here, and I think this will show you why some of the earliest efforts in political science to work with compositional dependent variables didn't get very far. These are two of the types of figures that they use to represent compositional dependent variables. And what we've got here is a simplex plot and then a ternary plot. And they're basically trying to show 3 dimensions of data in a 2-dimensional space, and they're difficult to read. I mean, I love statistical graphics, and I looked at these a lot, and I've gotten a lot of headaches from them, frankly. But and try to imagine if we went to a 4th dimension here, we would have to, it might be possible in this one by doing some kind of color shading, but then it would really be tough on the mind to try to figure out what was going on. I don't know that this kind of plot could be pushed to a 4th dimension even at all. And this is from a paper by Gary King and Jonathan Katz. This is a 1999 paper in the American Political Science Review, where they were modeling support for the 3 main UK parties across districts, so very much a cross-sectional analysis. A Scottish statistician, John Aitchison, developed in 1986 this idea of a log ratio transformation for taking compositional variables and unbinding them from the simplex and basically creating a dependent variable which is a log ratio of all other categories to one baseline category. And then what we're proposing is to do the Aitchison transformation, absolutely, and then estimate the short and long run dynamics. In our initial work on this, we used an error correction model, and when we have more than 2 categories, we use a seemingly unrelated regression estimation approach, a la Zellner, and then one of the big moves that we made early on was to use the software written by Gary King and his co-authors, and which is the Clarify software, to do a dynamic simulation. Clarify was written for cross-sectional data purposes, but we, in some earlier work that I'd done, we'd done dynamic simulations, and we used these dynamic simulations, basically taking Clarify and extending it to a temporal domain, and then we basically produce graphs, and so yes, we have a big nerdy system of equations here. Basically, what this is just showing you that we're doing an error correction model, a system of error correction models, and this is again in our initial efforts. We've since moved mainly to doing an autoregressive distributed lag approach. So we've moved away from the error correction approach, and I'll be happy to talk about that more in the Q&A if people like. One of the main points here is that this thing results in a heck of a lot of parameter estimates. So if you look down here, we got j-1, where j is the number of categories of the dependent variable, and then that's multiplied by k times 2 plus 2, where k is the number of independent variables. So you can see that that you very quickly get to a place where where you just have table after table after table of numeric output. And the numeric output is like a multinomial Logit's output in that you're having everything is in marginal effects on logged ratios, where in a multinomial Logit it would be logged odds ratios. We're just logged ratios. But you also, because we're in the error correction framework, you also have short run and long run effects, and then these the error correction parameter going on. So it's really complicated, and basically all you can get from the tables after tables of results is the direction of an effect and whether or not it's statistically significant using the usual standards. So we felt very early in this project that we wanted to move to graphs, and to do so we use these untransformation equations, which move us back from these logged ratios through exponentiating. They move us back to predictions that are in shares of the composition. And our initial work on this was what we call a change from baseline simulation, which I'll show you, and then I'll talk through all of this stuff. So just to show kind of the calculations behind this, what we do is we set the categories to some arbitrary level, usually the mean, and then we show basically a flat scenario. In this one at time 4, we introduce a change to one independent variable right here, which we're calling xt star, and at first that shows up as a short run effect, and then it starts to work through as a long run effect, and that's the mechanics behind these change from baseline simulations. But when I show you the graph, I think you can see that it's actually even though there's a lot of complicated machinery behind it, it's a pretty intuitive graph to read. And so this is a scenario based on our first models, again using Harold Clark's wonderful data from the UK, and what we have is support for 3 parties: the Liberal Democrats in gold here, the Labour Party, which is the party of the Prime Minister, in red, and then the Conservative Party here in blue. And we've run 9 time points of nothing changing. So that's the baseline. And that's why we call this a change from baseline graph, because at period 9, we introduced that shock. Back here, it was at period 4. And so in this particular graphic, we make it at period 9. And the shock that we're looking at here is when there's a large increase in the popularity of the Liberal Democratic Party's leader. So they get a big boost. Maybe they want to debate or something of that nature. And of course, that leads to an increase in their support. And we can see, it comes at the expense of both Labor and the Conservatives initially. And then after the initial burst, we see that some of that wears off, and we settle into basically a new equilibrium for the Liberal Democrats, but it's at a higher level now. Labor actually makes back almost all of their short-run loss very quickly. The time scale here is monthly, but we see that the equilibrium that the Conservatives land at here is below their starting point in this scenario. So right away, we're able to see what I think is a very interesting trade-off when the Liberal Democrats gain support here, based on their leader's popularity. Who does it come from? Does it come from the government party or from the main opposition party? And the answer here is it comes at the expense of the main opposition party, in this case, the Conservatives. And keep in mind, if we were using the established modeling framework, this red figure here is all that we would be able to see, and the blue and the gold would be lumped together. So we always like to, in the United States, we always like to have these before and after pictures, right? Like if we're trying to sell people on some kind of weight loss plan or something like that, they show the person, in one picture, pretty portly, and then they show them, thin and smiling in the other picture, the before and the after. So this is Katz and King with the simplex and ternary plots, and this is Phillips, Rutherford, and Whitten. And I think these are just much more intuitive, much more friendly. I showed this to Gary King, and he was like, "Oh, wow. I remember those ternary plots are awful." But, his graphics have changed a lot since 1999. So he thought that was pretty funny, the before and after. And another one of our early efforts is we also, as I've been saying before, a lot of this was motivated by political budgeting, and this is an example from our second big example that we did in our first paper, which is this is from the U.S. budget, where we were modeling 5 budget categories just to show that that we can handle more than 3, whereas of course the folks who are showing us ternary plots and so on really can't. And so, I think when somebody presents you with a new method or a new strategy, methodological strategy, like what I'm trying to sell you today, I think that there's at least 2 major questions that you should ask. One is, what problems does this new method solve? And then second, what do we gain in terms of our substantive understanding of the world from using this new method? There's clearly costs, right? Because it's not it's a little bit complicated. We tried to bridge some of those costs by writing software that's easy to use. But basically, I think you have to always answer those questions. What I would say is that, what problems does this new method solve? It's not solving any statistical problems. The old method certainly wasn't biased, but what I would argue is that we're moving you closer to what goes on in the real world. And as social scientists, I think we always want to be pretty close to, in our models, to what's going on in the real world. And then what do we gain in terms of substantive understanding, in this case of politics, from using this new method? And what I would say is that, we gain a lot, and we gain basically we're able to parameterize the trade-offs that are going on. We're able to talk about, here in this case, does a drop in unemployment, does it lead to a statistically significant change in the spending across these different categories? And what categories go up, what categories go down? But just to kind of drive this home a little bit, here's an example. These are 2 awful tables, and I apologize for all the numbers that are probably hurting your eyes right here. But this is modeling defense the kind of old way. And what we see is that there's only 2 variables that achieve statistical significance at conventional levels, and that's having a Democratic Congress and then having a higher old age dependency ratio. And you might be prone to concluding that none of these other variables affect defense spending. And in particular, what I would say is, here's a big variable in American politics. This is the policy mood variable made famous by Jim Simpson. And so it's kind of a surprise that in this model, we're saying, that policy mood, people becoming more liberal or conservative in the United States, the general population, doesn't have any effect on defense spending. And isn't that odd? And actually, that's not what you should infer from this model. What you should infer is that when you look at defense spending relative to all other areas of the budget, policy mood has no effect. And so when you move to our models, where you're looking at all these different areas of the budget relative to each other, what do we see? We see a lot more variables are significant, including now we see two trade-offs between Social Security spending and defense and between interest payments and defense that are driven by policy mood and are statistically significant. So, you know, what you're able to find is a much richer set of inferences, and I would argue that's much more close to the political action. You know, when you look at debates in Congress and in the media, when people are talking about raising the budget in one area, they mostly talk about, well, where are you going to have cuts if you're going to have raises in the budget? And you know, of course, it is possible that the entire budget goes up, but people still in budgeting politics, even when the entire budget goes up or down, they still look at what areas are gaining in relative terms or losing in relative terms. But that's actually something that we could come back to a little bit. In our work, we call the entire budget getting bigger or smaller. We call that changing size of pie. And I'll be happy to talk more about that. We've done a fair amount of work on that. So our initial papers, we published a paper, as I said, in the American Journal of Political Science, and kind of announced the dynamic pie program there. And then this is our first piece of software, which we published in the Stata Journal. And we now have a second piece of software, which just came out in the Stata Journal as well. And we have an R package, which is in development, I hope is going to be available in the spring. But we're kind of one big problem away from getting there. And so that was the initial launch of the program, of the Dynamic Pi research program. And I'll just kind of walk through some of the things that we've done in the time since then. One was another paper that my good friend Harold Clark accepted in electoral studies when he was the editor there. And this was a paper where we made a move towards a mixed logit type setup, which basically meant we're allowing for changing attributes of the categories through interactive specifications. And this is something that we are now coming back to after kind of a long time of not doing it. But there's that paper in electoral studies. And I'll just kind of buzz through this. To do this, what we needed to do is we needed to do an interaction inside an error correction model. And this is just an example of the kind of things when I talked about how Andy and Amanda found papers from all over the place. This is from a paper on food safety. And basically what they were doing was they did an error correction model of the spot price for spinach. And they looked at the effect of an E. coli episode, major food safety issue that happened in the United States. And yes, it did drive down the price of spinach. And they made an argument that this really had a structural break. And so they needed an interaction inside an error correction model. And they did it, we thought, in a pretty cool and elegant fashion. So we basically followed their lead on that. And we were modeling party support shares as a function of kind of the usual suspects in terms of party support across months, but also looking at characteristics of the parties, whether they were in government or not. And we showed through graphs that this is looking at two change from baseline scenarios, and this is German data, and basically what we're showing is that up here when the SPD is in in government, they experience a much bigger shift when their leader at the time who was the chancellor, when their ratings go up than when they're in opposition. So we're basically setting up the same exact scenario as a counterfactual, once when they're in government, once when they're not, and we see the differences between the two. They're not really anything to write home about. They're not absolutely massive, but they demonstrated that this idea of modeling not just changes in the circumstances, but also changes in the parts of the composition in their characteristics have an effect. Another big move that we made, we actually did three new things. It was in and this gave us some ideas of some additional projects. This is a paper that we published in the Journal of European Public Policy. This was our first extension to time series cross-sectional data. And we have some other types of interactions and effects plots. Oh, and it's also our first ARDL type specification instead of an error correction model. And so actually I guess there's four innovations there. And our theoretical framework was basically thinking about left-wing and right-wing governments and what are their general priorities, what are they going to be most responsive to. We thought the left would be most responsive to immigration, the right would be most responsive to labor market integration, and as a result of those priorities and their responses to stimuli, what are the areas that they're gonna prioritize? And so they have different budgetary priorities here, and so here, we're doing a simple lag dependent variable setup, but we're interacting everything with whether the government is a right or a left wing government, and this is an example of the inferences from this. You see, we have the same change from baseline graphs, but then we also came up with a new graph, which is what we call an effects plot. And this is kind of closer to a hypothesis test, because you can look and see whether, in this case, the long run effect is statistically different from zero. And initially, we had these ideas, and putting the same scenario with a left-wing government and a right-wing government on top of each other allowed us to make these comparisons. But also here, the other cool thing we thought about this was that you could see that this is in a reaction to an increase in immigration, and we can see the right-wing government certainly reacting, but the changes aren't nearly as big as they are for the left-wing government. And so we started thinking about the overall change in the composition under different circumstances. In this case, a left-wing government versus a right. And then here's from an integration shock, meaning that the economies are more closely integrated. And what do we see? We see that the right-wing government reacts much more, as we expect, while the left-wing government reacts some, but nowhere near into the same type of magnitude. And so we started really getting interested in this. And I guess our initial thinking on this was that it was kind of like an Arch or a Garch model, but that's actually not exactly what it is, because what we're looking at is variation in the dependent variable from one point in time to another, and sort of perturbations or overall changes in the composition, where an Arch and Garch model is looking at the ability to accurately model the dependent variable. And it may be the case that the model is less accurate when you have bigger changes here, but we're interested in modeling that variation rather than the error variation. And it took me a while to kind of wrap my head around that. I'm happy to talk about that a lot more too. So that was, extending it to time series, cross-sectional data, and then the next one of the next papers we did. I wish I had given my talk before Andy Phillips, because this was, I think, kind of a bridge too far for us when we started doing spatial econometric specifications within these things. Andy's a very gifted mathematically and statistically, and I've never seen him so frustrated as when we were trying to make these models work. We initially did this
guy, and in tradition we believe that we save the best for the last. Save the teacher after the student. Sorry, and I'd be bad.
Oh no.
Next time I can talk to you and let you go first. But I think this is
a
better sequence.
Yeah,
Indeed.
no. It's just
they gave a great talk last week, and then that laid a really good ground for us. Hey, the better one's coming after Phillips.
Well, he's very kind.
Okay.
Yeah, I don't know.
All right, sorry, interrupting. Yeah.
Oh, no. I'm happy to be interrupted.
Yeah.
But one of the things here, just talking about strategies, we thought about doing a SAR model, spatial autoregressive model, and it just was so complicated. So we thought, well, let's submit to the journal doing SLX models, and hopefully that'll be enough to get us an R&R. And I'll bet you that the reviewers are going to ask us for a SAR, and that's exactly what happened. So we, at least when we were going to go after the real difficulty of having all the moving parts of a TSCS model of a compositional dependent variable combined with a spatial autoregressive term in them, at least we were doing it with the prospect of an R&R, completing an R&R. Because I don't think we would have done it otherwise. If we had submitted it in the initial paper, who knows what the reviewers would have asked us to do. So just a little bit about strategy there, that they were really, really tough. So that was that paper. And and I guess some of the more recent stuff that we've done, we've extended it to modeling inequality, and that's been some really exciting work. That paper, I think, just came out, or is just coming out, also at Political Science Research and Methods, and just as this JEP paper gave rise to a bunch of new ideas about compositional volatility, this work that we did on compositional inequality gave rise to some new problems and new ideas. And so I'll talk about those a little bit. And so, projects that we have in projects, we've got progress. We have a book contract with Cambridge University Press on comparative political budgeting that I'll talk about a little bit. Different modeling strategies for size of pie when budget sizes are going up or down is a big part of that project. And then also we have this business about compositional volatility. So let me just show you guys a few figures from that. This is this in one figure. I think the last time I compiled this book, it's at 320 pages, and we still have a little bit more writing to do. This is one figure summarizing everything that we do in the book. So basically, what we think about is that government ideology and then the core supporters of political parties will drive the general priorities of those parties. But then events, as Harold Clark loves to say, I think he's quoting Harold Wilson there, events, dear boy, events. And we're thinking about events in terms of electoral considerations, institutional powers going up and down, economic circumstances and international circumstances. They all together combine with general priorities to create the feasible shifts. So as you can see, as you might imagine, we have a lot of interactions in our pie models. And of course, the past composition of the budget determines the present composition. And this is basically a lot of our earlier work had some of these ideas, but not as firmly worked out. But then this is just expenditure change. And then of course, there's other parts of the budget, total expenditures, total revenues, budget deficits. And of course, those are all shaped by external events as well. And we're doing some work that I've found really fascinating using panel VAR models for the lower part. So the pie models are up here, and then the panel VARs are down here. And I'd be happy to talk about those more. This whole idea of compositional volatility, as we were preparing for the book, we stumbled on this two papers that have been really well cited, one in the economics literature and one in the political science literature. And they came out very close to each other in time, but they don't address each other at all. So it's kind of a case of parallel evolution. The one was by Brender and Drazen, two economists, and another one was by Sibelius and Chang, two political scientists. Sibelius, of course, is famous for his work on veto players, and the idea of this is to take they take a compositional variable like this. This is the UK budget from 1975 to 2010, and they collapse it down into 1 year and 4 year changes. So the total change from the last year or from the previous year. And so you can see that this is the red and the blue lines here are basically summaries of the volatility that's going on in this compositional variable. And they've done some models of that. And what our thinking is, and our kind of innovation here is to say, okay, so we're able to model this, they were able to model this. Why don't we do models in which we combine these two and look at feedback loops between them? And so that's where we are with that particular part of our work. And that's still very much in the early days. As I said, we've been doing work on income inequality, and that's given rise to another issue, which we call the continuous pie problem. And this is something where, basically our approach to income inequality, it starts with a figure like the ones that Thomas Piketty and Sands and some of his co-authors have made famous, looking at the wealth trajectory, in this case in the United States, of the wealthiest 1% of the U.S. population. And Piketty has published all these papers and books on this, just doing descriptive statistics of the share of the top 1%, sometimes it's the top 0.1%, all the stuff like that. And it's been incredible work. But our question for Piketty is, what about the rest of the pie, man? This is a compositional variable when we think about income shares. And so taking this, not this exact same period of U.S. Political economic history, but almost all of it, here's the story where we only have the top 5% in this particular data view, but we can see the other groups. So, when the income share of this top 1% goes up or down, we want to ask the question, who does that, at whose expense? Who declines in relative terms? And we've collected a bunch of data, and we've got 3 papers on that now, where we're modeling income inequality as a pie. And the problem with the continuous pie is that income inequality doesn't have discrete categories like support for political parties or spending in a particular budgetary area. Instead, it's a composition, and it can be broken down, almost in an infinite number of ways. And so that's something that we're really fascinated with. And what we're showing in our papers is the robustness of our results to different ways of breaking out the income pie. And we're even talking about some software that would allow people to look at that kind of in an automated fashion. Another thing that the income inequality work has led to is what we call an endogenous pie model, and this is something where I think that old school modelers like myself and Harold, when we're faced with the causal inference crowd, our good friends in the causal inference crowd, where we can really push back, because one of their critiques of regression-based approaches to social science research is to say, well, you don't know that Y isn't caused. You don't know that Y doesn't cause X. You're saying X causes Y, but Y might cause X, or there might be both. And so these VAR models and other models allow us to say, well, okay, fine. Let's go ahead and test it. We don't, it's sort of like the old bear in the woods argument, where they're sort of saying there might be a bear in the woods, so you guys shouldn't run these regression models. And what we can do in the time series setting and the time series cross-sectional setting is say, oh, you think there's a bear in the woods? Let's go meet that bear. Let's model that bear. And so I think that there's there's going to be a lot of payoff to these VAR models in the next couple of years. So this is kind of where we start. We're looking at the effect of polarization, and there have been other studies that show that polarization really benefits the top income group, and we find exactly that. But what's interesting, you can see by doing a dynamic pie approach, is that we see that it's not just the top group, it's also the next group. So we've got 80 to 94%. And then when we look at which groups does it come at the expense of in relative terms, it's not coming at the expense of the lowest income group or the kind of upper middle, but it's really coming out of the middle income groups. And these are questions that when you only model the share of the top 1% or top 5%, you can't ask. And I think it's a really logical question. Like, so when the top group, when the wealthiest of the wealthy get wealthier, who loses out in relative terms? And then looking at kind of flipping it back around, this is, you could easily say, well, hold on, wouldn't we also think that that income inequality, rising income inequality, would cause more polarization? And absolutely, we might think that. And what we're able to show in our VAR approach to the pie models, what we call an endogenous pie model, is that exactly that happens. There's a little bit of a lag after an increase to the income share for the top 1%, but it does lead to increased polarization, in this case 4 years out. So we're able to model the endogeneity, and we're able to show that in this case the causal arrow actually flows both ways. So that's some stuff that I've been really excited about. Another thing that I've been very excited about is the new software and what we've been able to do with that. The second version just came out in Stata. We've got more flexible modeling options. You can do an error correction model. You can do an ARDL model. In the ARDL in particular, there's lots of options for doing interactions. We've got, of course, we have the change from baseline figures, but now we have it set up so that you can have multiple shocks. So if you want to simulate, 2 or more changes to a particular independent variable, we have those effects plots, which I showed you, and we have some coefficient plots as well, which I think are pretty interesting for getting an initial look at the results from your models. And as has kind of been the theme for this project, as we were coming up with new plot types, we kind of thought about a paper about the way that people have interpreted their multinomial logit models. So that's another spin-off project that has come out of this, and this is why it's really nice to have a big research team. But I'll just show you a few graphs from it. This is the same kind of change from baseline plot that we saw before. These are those effects plots. You can show both short run and long run effects, as we've shown here, multiple confidence intervals, which is kind of cool. These are coefficient plots, which you can show. This is just a way, as I said, I like this for eyeballing, like what's conservative and what's not. Sorry, what's conservative, what's statistically significant and what's not. And then if you want to say, instead of looking across, just one category relative to the baseline, which is what you're seeing in each of these two figures here, what we can do, we can look at them all, but we can also look at the effects for one particular variable and see which trade-offs is it significant for. So this is a way of looking at the entire model, that this is the same results here and here. They're just two different ways of looking at it. Here we're looking by dependent variable category ratios, and here we're looking at it by independent variables. I'm happy to, I know I've rushed through a lot of this because I realized it was going quite long, but I'm happy to come back and talk about any of this stuff. But I hope, if nothing else, I've convinced you that dynamically interesting compositional variables are everywhere.
Wow.
Thank you.
Wow. Thank you. This is really overwhelming to me, because you presented as a series of articles you published out of this idea of dynamic pi. And I think we'll just go for the rest of the program like this, and I will get started with some questions. I have some questions already. I would really like to learn from this dynamic pi idea. Then I will invite students or participants from both sides to ask questions. You can raise a voice, or you can type the question in the conversation box, or Professor Pan can do that, collecting questions from the floor. And also I will invite, of course, Dr. Clark to ask questions. And before I have Professor Clark come in, and let me ask a few questions. I think I'm really impressed by this innovative project. This is a great idea. And when I was a graduate student, I attended guys' talks and multiple talks, and we talked about, introduced as multiple multinomial logits. Now we put multinomial logit in multiple and dynamic context, because you're not doing one model. You're looking at like multiple models. Now I have quick questions to start with. Now, so you have some assumptions about these compositional dependent variables that follow a zero-sum combination. So that means that I'm sure you may also address what if there will be positive sum in future. I'll talk about that later. But one question I want to ask is, hey, now you can compare the models, the results, by the number of slices that you have. For example, you have 2 slices in the U.S. Electoral case. In Taiwan case, we are primarily 2 slices too. So the green cam and blue cam. So will these be the most may call it easiest model to start with? Then the more the slices, and what will the dynamic pi become, and will there be more variations and variabilities that you have to find other ways to model, to estimate? How's the number of slides come in?
Yeah, so it comes in exactly as it does in a multinomial logit model, where you can, theoretically, you can have as many slices as you want, but frankly, you have an S curve in a binomial logit, and of course a multinomial logit also has an S curve, and the point of inflection in the multinomial logit, so where the impact of an independent variable is steepest is at 1 over j, where j is the number of categories.
Yes.
And so at a certain point where you have 20 categories or something like that, the model it doesn't break down, but it becomes a bit unwieldy. For instance, I've done a lot of work in Brazil recently, and there it's not unusual for 24 parties to end up getting shares of support, and you can model support for all 24 across time, but it's just unwieldy, and I actually think if you really want to do that and get away from the problems of the multinomial logit and the point of inflection, what I think you can do is there's a VAR version of this model that you can do, and that would be my recommendation there. But if you wanted, if you have 10 categories, this model is just fine. And we've done some examples with 10 categories. So probably somewhere between 10 and 24 is where we hit the limit. But when you divide 100% of the vote among 24 parties, you get a bunch of really tiny parties, and there's not a lot of action, right? They're just kind of they're rounding error at some point. And so I've kind of encouraged my students that are working with those types of data to maybe try some party groups, like in Brazilian politics, when they talk about legislative coalitions, for instance, one of the things they talk about is the central. And the central is this group of tiny little parties that even political scientists from Brazil can't name all of them, but they're known as a bloc, and they kind of do business as a bloc. And like Bolsonaro just passed a major stimulus package by making an alliance with the central. And when you look at the news coverage of it, they talk about the central. They don't talk about all the little, dinky parties that are in the central. And so I think a lot of times you can kind of amalgamate and do more meaningful analysis by combining categories. But you can absolutely test the robustness of your results to different, putting things together and taking them apart. And that's something that we're pretty excited about, and we're trying to build into the software as well.
Yeah. And my other question is now it reminds me of something when I learned in econometrics, and does it resemble something like a system equation models, and then you have a system with equilibrium? So if all these system equations, so they may compensate for each other like an equilibrium. Where there's something similar to that, but you put much more dynamics. Of course, it's like over time and over space too.
Yeah. So that log ratio transformation that Aitchison invented is what keeps the compositional constraint in place. That at any point in time, when you exponentiate, those percentages are going to add up to 100%, or 1 if you're doing proportions, right? But there also is the time series equilibrium, where if you shocks to the system wear off through the lag structure or through the error correction mechanism, depending on which flavor of time series model you're talking about.
Yeah. So, I have one more question before I
great.
Professor Clark. Now, and that something boggles my mind is about the other category. For example, so you have now I teach data visualization. So cognitive science teaches us that human perception can deal with 4 to 7 categories simultaneously. Beyond 7, it'll be difficult for you to process. So what about, now this is a different thing. What about the other category? We have, do we need to assume that other category is pretty much like always like a general constant? That means, for example, other category like I never choose a party or I never have a strong identification to either party. So these outer category, does it have to be like a more like constant in the long run? Now you show that chart now. Yeah.
Yeah. So here, this was from the U.S. budget example, and this is kind of funny story, Carl, because I actually didn't know very much about the U.S. budget. I just kind of live here. I don't really study this country like Harold does. But Amanda kept showing me these graphs of the U.S. budget data, and the other category was often the largest category. And I was like, "What? We can't have that. Like we're trying to say that we want to model the budget." She's like, "But Guy, this is a well-known fact in the U.S. budgetary data that the other category is always the biggest category." And I was like, "Well, no, I don't like it. I don't like it." And I said, "Let's go," because we were doing in this view, we did the 4 biggest categories and then everything else in the other. And I said, "Okay, well, give me the 5 biggest." And darn if that other category still isn't the biggest category. And we kept going and going and going. And finally, she convinced me. And in this case, the other category, what we found that was kind of interesting was that when mood went to the left and when the Democrats were in power, that other category went up. And I was asking Amanda about that, and she said, "Well, it's because the Democrats create new tiny little budget categories. Like they're generally the party in favor of larger government. And so it actually does make sense substantively that the other category would go up under the Democrats and go down under the Republicans." But yeah, I mean, for sure in the UK data, right? You know that, I mean, I guess in the time that we were looking at, UKIP was a tiny little party down at like 1%. The Greens were around and they're barely getting any support. And so, we made the decision to only go after the big 3, mainly because that's what Katz and King and the others have done. And so we wanted to have it as a good, clean comparison. We could have easily included more parties. But you're always going to have another category. One of the things we were really interested in was when a new party comes on the scene. And unfortunately, the public opinion data on that just weren't very good. And I mean, I can explain that a little bit more, but I think, the other category, it's something that's there in compositions. You can't get away from it.
That is really interesting. I think that particularly the illuminating part is the budget and the other category, and also your Democratic Party proposals example. That begs to my other one more question about the substitutability of these categories. For example, you showed that example about the Liberal Democrats rise at the expense of the Conservatives, but not at the expense of the Labor. does it shed light on whether the categories, some categories are substitutable to others, but not substitutable to others? For example, you put in now your budget example is a good illustration too. So whether the Congress is willing to cut budget on defense at the expense of education, social welfare, or at the expense of other categories, are a good example. So it could be always that something you can cut in another category, but some other categories may not be substitutable, mutually substitutable, right?
Yep. And that's exactly what we're modeling, Carl.
Yes.
And that but it's even a step further, right? It's not just that, this budgetary category and that budgetary are substitutable. It's under what circumstances are they substitutable? So here we're looking at, suddenly there's a drop in unemployment, right? Which is something, of course, we're hoping to have very soon. And what we see, we see the sort of aggregation of outcomes. Well, when you look at the table of parameters, you can see whether the trade-off between Social Security and welfare, Social Security and interest payments, Social Security and defense, whether those are statistically significant due to a change in unemployment. But they, and just because they're significant, the trade-off is significant between those two categories from an unemployment change doesn't mean that they could have a completely different relationship, trade-off relationship, due to an increase in growth or the U.S. getting involved in a conflict, right? So that's to us, that's really the beauty of this set of models, is that we can look at the trade-offs, which are very much context bound, and under what context will we see this trade-off? Under what context will we see that trade-off? Yeah.
Yeah. In this case,
from people asking questions exactly like the one you asked, that's why we started moving to these graphs of the parameters, right? It's like, these are answering exactly those questions. Does this variable, what are the trade-offs? And here we have all possible pairs.
Combinations.
Yeah, exactly. And which of them is it significant for, and which is it not? And so, here, if we're looking at labor and conservative, it's significant here, it's significant here, it's not significant here, it's not significant here. So there's just a lot of different things that you can get at from one model.
It's really highly informative. There's a lot of things come out from this, from these combinations, and there's so many combinations. I think I asked too much. May I invite Dr. Clark? Great answers. Thank you, Guy. Dr. Clark, do you have any insights or questions for us? Yes, I can hear you. Yeah.
Okay, great. No, wonderful talk, Guy. Really terrific.
Thank you, Harold.
Research agenda, and I know you've been working with some great graduate students. Been very fortunate to have guys like Andy,
unbelievably fortunate,
so on, people who I've met over the years, and so that's a really terrific program. I had two ideas. These are things you may well have already done, and one of those follows on from in a general way, at least from what Carl was saying. I was thinking in terms of voting models, of time series voting models, where you are looking at not just the conservatives, but Labour and the Lib Dems. To use the British example, one of the most recent interesting developments in the British case, of course, has been changes in turnout, with flooding into the Labour Party, both as voters and also as supporters and members. And I was wondering, it seemed to me, and you may have already done this, it's a fairly obvious thing, but it occurred to me that one of the really neat ways of modeling some of these voting pies would be, of course, to take. Often we don't pay any attention to the non-voters, And so we do our division, the percentage, the conservative percentage is the percentage of voters. But I think it should be the percentage of the electorate, because I think there'd be some insights there that you would get in terms of where changes in support are coming from over time.
Yes.
Yeah, absolutely. The main limitation that we've encountered in our time series work is that, and I mean, you tell me with these data, I don't think there's a really good measure across time of people planning not to vote. They're asked, if there was an election, next week, who would you vote for? But I don't think that, and I mean, there may be some questions in there periodically of that say, would you vote if there was an election next week? But I think most of the time that doesn't get asked. But one of the things that we've been doing is we got interested in going back to the old cross-sectional pie models. So there was the one that I showed you guys some results from by Katz and King, but there was also a pretty famous paper by Toms, Tucker, and Wittenberg, and they showed that they could use a methodology much simpler than the one of Katz and King. They used an SUR framework to estimate, and their problem was what they call partial contestation. So they basically ignored it, the fact that some parties don't contest every seat, right? And so they just basically took out all the other parties other than the Lib Dems, the Conservatives, and Labor, and just modeled, the share of major party support, essentially. And they said, oh, but you could deal with this problem of partial contestation. And what they suggested is run a different model for each pattern of contestation. And to us, that's just crazy. That's just really clumsy. So you run one model for every district that has the Lib Dems, the Greens, the Conservatives, and Labor. One that only has the three big parties. One that the monster raving loony party. It's really unwieldy. And that paper has, I think, like 120 sites. And what we did a quantitative literature review on that. And so far, we haven't got the final numbers, but something like 80% of the papers that cite it say that, but we can't use it because of partial contestation. So we're trying to model the partial contestation. And as a part of modeling the partial contestation, we're also modeling turnout as a factor. And it's exactly like the size of pie in some ways, where when the overall budget goes up, some categories benefit at the expense of others. So we're modeling turnout in actually two different ways. One where it's an independent variable, and this is an old idea that when turnout goes down, it hurts the left-wing parties kind of disproportionately, because the supporters for, say, like the Tories in the UK, the Conservatives in the UK, are diehard voters. Like no rainstorm or hailstorm or whatever is going to stop them from getting to the polls. But the folks
older,
and just more kind of, for whatever reason, they have maybe greater freedom of schedule because they're not working in a factory, all that, whatever, I don't know. So we're modeling it in some cases as a separate share of the pie. So what proportion of people are making the decision not to vote, and then sometimes as the size of pie thing. But I think there's real utility to that, Harold, and I think it's I think it's a great idea. Thank you.
Yeah, I had one other, if I could, Carl. This is just one of the things that's always neat, and I know you've done this with a number of other things. You probably have done it with this project as well. is to actually do some simulations. And I'm thinking, for example, suppose you're interested in Liberal Democrat support in Britain. I'll use that example again. And one way of doing this, you're using the data that we had, or whatever, that we had generated. You say, okay, well, I'm just going to develop a time series of Lib Dem support, and I'm going to start in January 1992, and I'm going to go all the way up up maybe to 2015 or whatever, 2017. And so I just do it as a regular time series, and I put on the right-hand side, I put some economic variables, and I either subjective or objective, and I put in some shocks and so forth, and leader changes. And so there's a fairly standard, sort of model, except that we're doing an opposition party and a relatively small one. And I'm wondering if you do that, and then you compare it to doing the compositional approach. Do you draw different kinds of you get different stylized facts out of it? Do things look, the coefficients might be different and so on, but really, do you get a different story? And I'm wondering if you could actually formalize this a bit by doing some simulations, because I think that would be really a really nice demonstration to the profession that, hey, there's a real payoff here in terms of the stylized facts that you gain.
Yeah, it's really interesting. I just to make sure I understand you. The change from baseline scenarios that we're doing are model-based simulations. So they're exactly like what Gary King is talking about with the Clarify software, but we're doing kind of counterfactuals where and we're doing them over time where they didn't do that, and saying things like, well, what if everything stayed the same, but the Liberal Democratic leader suddenly had a big boost in their support, and everything else stayed the same across the entire time period. That's exactly what's going on in that. I can put that back up, maybe. Let's see. So that's what's going on here, right? But you're saying if we compared the simulation here to the same exact simulation in a model that only modeled the percentage of support for the Lib Dems. Is that right?
Yeah, imagine you did this. Imagine you developed a you put together an artificial world where you have over time variance in the support for, we'll say, three parties, who make the smallest case, I guess, where it would be useful, just to make A, B, and C or whatever. And you say, okay, there I've simulated this, and I know what kinds of, I've built in some shocks, and I've got some x's on the continuous x's. And so suppose, though, you say, I'm the average political scientist, the APS here, and I come along and I'm just going to model. I don't know anything about this compositional simulation or anything. All I know is that Professor Whitten gives me these data, and I model the Lib Dems, their C or whatever. And I'm smart enough to pick out the same predictors that you used to develop your pi model, a dynamic pi model. But I don't know anything about dynamic pi, so I just model the Lib Dems. And then somebody else comes along, one of your graduate students who knows all this stuff because you taught him, and so he does it the right way, quote unquote, or with the dynamic pi approach. Will you get different results? And if you were to run this like 50,000 times or 100,000 times, imagining many more graduate students than you'd ever want to have, to be able to demonstrate that, hey, you can really get it wrong if you take a traditional approach, I think would really help to sell this to a lot of people. And I just wonder, you may have already done it. I don't know.
So I think my intuition on this is that if you just modeled the Lib Dem share and did a dynamic simulation, you would recover exactly this figure.
Okay.
But what you wouldn't know is when their support goes up, at whose expense did it come? So you would, right, by definition, because you would then be modeling the libdems versus everybody else. And
that's right.
And so you wouldn't get like biased results or anything kind of technically wrong with the model, and you could get these exact inferences. But what you would be missing is who did it come from? And of course, since these are correction models, and all of our models are time series models, you get a short run and a long run effect. And here, the short run effect is it comes out at the expense of both, but the long run effect is that it comes much more out of the conservative side than it does labor. So yeah. But
just one last comment on the VAR models, Guy.
Yeah.
In terms of looking at the impact of shocks over time, how did you use like the Cholesky decomposition there? There's a sort of a nerdy question, or did you use like the Passarin and Shin generalized impulse response function?
So that's been the devil in the details here, and that's what's really slowed that part of the project up, trying to use different decompositions
the Passarin and Shin one is neat. At least it's an average. It averages overall possibilities. So that one often is one that will silence critics of the Cholesky, But I can email you about that, but that's just a note.
Yeah, I'd love to get your
really
thoughts on that. Thank you very much.
All right, thank you. Let's pass the mic to Peter on the Taiwan side. Peter, do you have any question from the students or from yourself?
Sure.
Yeah, and let me put you on in the spotlight now.
No, that's okay. Yeah. Well, thank you. First of all, I have to say thank you to Guy, and I believe my students and myself too are very much inspired as well as overwhelmed in a way by the substantial insights that the dynamic pi can offer. So here I actually collect a couple of questions. One of them actually following Carl's question earlier, as you have mentioned that the model, you model the bigger shares or the bigger shares of the budget, including the other category. So can we try, or have you tried digging into the other category and analyze more sub-policy areas, sort of, micro view on some particular policies within that, those areas consisting the other category? Can we do that? That's the first question I have. And also some of the students interested, could you introduce the software or the package a little more? Because we're wondering, will it be available for our audience or other researchers for a test drive? We're thinking about that. And yeah, so that's the first question, two questions that probably you can share some.
Yeah, absolutely. So in terms of looking at the other category, we absolutely did that. That was actually, if you look at the supplemental materials for the American Journal of Political Science paper that we published, we looked at 5, 6, and 7 categories in addition to 4, and so that's and each of those progressions, what we're saying is let's add the next biggest category, so pull it out of the other and bring it into the budget, give it its own category, and so that's the place to look for that. In the work that we've done on budgets in other countries outside of the U.S., other isn't the largest category. Their budgets, those are the budgets I'm used to looking at because I I've tended to focus on Europe in my own research. So so there, in that literature, really, there's kind of an established protocol, if you will, of what categories of the budget people look at, and that was actually really kind of nice for us. And if I can show you here, in European budgeting, analyses of budgets in Europe, these are the 8 biggest categories that you see. Mm-hmm. And this is like the World Bank data does it this way too, in terms of sorry, not World Bank, IMF breaks it. These are the big 8 categories, and their classification, when you move beyond the big 8, you get into subcategories underneath, like, so you get into subcategories of social protection. Now, some of the other folks that are in the dynamic pi group, so these are actually some projects that I'm not involved in, have looked at what they call the pie within the pie. And mm-hmm. and what they've said is, like, let's look at just welfare spending, and when there's changes to the welfare budget, or when there's external stimuli, you know, how do resources shift around within the category of the different categories of the welfare budget, and you know, that's been some really interesting work, I thought, and there, of course, you do have the size of pi issue looms large, but it's, you know, the size of pi is everywhere, mm-hmm. And then in terms of the software, if you guys use Stata, you can download it. The 2 versions of the software. There's DinSimPi, and boy, I should know this. What the other one is here? Hang on, let me find it real fast.
I saw that. That is dynamic pi. Din, like a dynamic SIMPIE, right?
Yeah. Let's see. So here's the.
Do you have a Git?
Yeah. Let me just share this with you guys. I can show you the article that just came out. Mm-hmm. Here we go. Okay, so this is the, you know, in the Stata journal, and so the original program is DinSimPi. So if you're in Stata, you can do net search DinSimPi, and you'll find it, and you can download it right away. And then the 3 new projects are, let's see, CFB plot, effects plot, DimSimPi, COIF. Yeah, you got to give them all names, and so I think you can actually download that whole suite, and I can show you. If you guys want, I could actually show in Stata how to get them. Do you want me to show that, or are you guys familiar?
Sure.
With that? Why not? Right?
That'll be interesting to see live demonstration.
Why not? So let's see if I can make this work. So you just go here, you go net search, DinSimPi, and there, well, that's not it. 4 packages found. So here's an update. Okay, that's the update, and this allows you to just click here to install them all. And what if I had it on this machine? I already had it on this computer. So, but if you didn't have it would
prompt you. Yeah.
Yeah. And it's got, if you do DinSimPi, you know, it walks you through the syntax. It's all it's all there ready to go for a test drive, and you know, it's got all the links, and it's got examples of the commands that you could
ask. Yeah, could be also maybe that it's not showing on my screen. I don't know what it's showing on the screen in Taiwan. It could be, could be just a font prompt. Could be just a font prompt, and for the pop-up window. Yeah,
that's the pop-up. It was a pop-up window. Let me see if I can get that window.
And we can just do the net search, Dean Senpai in Stata. Okay.
Yeah, and then here's what the pop-up window. Yeah. Sorry about that. This is what the pop-up window. It walks you through the syntax and everything, and you know, kind of talks through. This is the old program, but then the newer ones would be the ones that you would get if you went. Let's see. So let me. Okay, so here, this is another pop-up window. Let me share.
Yeah, the pop-up will not show it for some reason.
I know. I'll get it for you. Here we go.
Yeah, could be just Teams. Yeah.
So this is the.
Oh yeah, this is right.
Yeah, and you would just click on the blue to install it. Sorry about that. Yeah.
That's great. No problem. That's great. Thank you. I think it should be very straightforward.
Yeah, clear.
State of user. Yeah.
And by all means, Peter, if you and your students give it a try and you find any problems, let me know. And I'll probably have one of my graduate students answer it because they did all the programming. But we'll get you an answer because we have a big team that loves helping people to use this software. And hopefully we'll have the software for R, before next summer would be my hope.
And for open source, that would be easier.
Yeah, of course.
Yeah. Here is additional extension, maybe extended questions. Could you name it just overall suggestions? Could you name a few more possible areas that the zero-sum dynamic pi method can apply to? So that's from the students.
Yeah. I mean, I think let's see. Boy. I mean, another place where I think outside of political science where you could certainly apply it would be in kind of portfolios. What proportion of or international trade would be a great one, where if we were modeling, let's say the time series of Taiwan's trade partners. Obviously, I think there's been an increase in trade with China in recent years. Maybe a decrease with some other partners. Like that would be that's a compositional variable, right?
That's a great example. Yeah, because of the recent change and due to the trade war, and also due to the change in industrial policy, for example. The semiconductor industry is so successful, and that particularly on I think there will be another area like seeing a regime change or paradigm change. So we can see just like in your chart, showing all of a sudden that and also a broad expanse how to trade off dynamics, some nuance within all this combinational trade off will be really interesting. And like a policy change and under different administration, or there'll be a shock, and there will be something that exactly that could be useful. This kind of paradigm change or policy change. Yeah, interesting. Yeah. Peter, do you have more questions?
That'll be all for now.
Okay. Yeah. Thank you. Great questions. Really appreciate it. Everybody's questions have been great. And I'll tell you, it's always fun to present this to different audiences and hear the reactions. I mean, it always ends up making our work better. So thank you very much.
Thanks,
Yeah,
guys.
we should say thank you. Yeah.
Thank you.
Dr. Clark, may I ask one more time? And do you have any remarks or questions?
No, I think that Guy has given a great presentation of not, this is not simply a paper or even a book, it's an entire research project, and it's really innovative and very interesting. Very interesting.
Thank you.
I hope that the students have enjoyed it.
Yeah. And I can use a real eye-opening and a real eye-opening to another world of modeling. When you look at all these combinations within this compositional dependent variable, so I can apply. There could be many applications, and maybe we should invite Dr. Whitten again next time to give more illustration, or maybe some demonstrate to us how we use that, how we interpret that, and. Peter, and what do you think about any students from the floor? Any questions from the floor, or any feedbacks, any remarks from your side, please?
Yeah, no more questions, but yeah, that was my wish too. I hope that Guy can come back and share more with us.
Always happy to come back and talk about pi.
Yes, and actually, just like Carl says, there is really eye-opening to me. Seriously. For the whole series and all the guest speakers that we have invited, and they all provided up to date and never ever have thought of it as methods.
Yes.
I think today it's another one. It's very insightful, very helpful. And
thank you.
I wish I could absorb them in a very quick and then just apply to my own research. That's my remarks. Yeah, thank you very much.
Yeah.
Thanks, Guy. Thank you.
All right, thank you.
All right.
It's a lot of fun.
Thank you, everyone.
Announcement.
Peter, Carl, student.
Yeah.
And just a quick announcement for next week. If you all have time, and we have invited Jeff Gill to talk for next Friday. Well, actually, your Thursday evening. So if you do have time, please join us in the audience.
All right.
Let's come back.
He always gives a great talk. Jeff does.
A quick note. Any materials, Dr. Whitten will give us the PDF, the slides, and we'll put it on the GitHub. The GitHub will be just you can just type go to github.com, type DA Colloquium, and that is our GitHub website. So you can get all the materials for all the previous talks and all sample programs, papers, and you can just use that as a hub for you to do the replication stuff. And all right, thank you so much. I think I will call the night, and thank you again, Dr. Whitten. And this is really a great night and of presentations. All these great ideas and really inspirational and illuminating too. And Dr. Clark and he already left, and I wanted can't say thank you enough to him. It's all basically the person behind all this colloquium. It's the list of guest speakers, and now all right. And I hope you have a good break and also successful conference tomorrow. I know you are hosting another big conference tomorrow at A&N too. All right. Okay.
All right.
See you.
Thank you very much.
Next time.
Have a good rest of your day, and good night to the folks in Texas.
Thank you.
Bye.
Thank you.
Bye.
Thank you. Thank you all. Okay.